Moving charges generate magnetic fields. In this diagram, the moving charges are represented by the green arrow, and the blue arrows represent the magnetic field that goes around it. Magnetic fields store energy, just like electric fields do. This means that to generate magnetic field, you need to supply some kind of energy. Once the magnetic field is generated, you no longer need to supply energy to maintain the magnetic field just sits there. But let's say you have a wire through which no current is flowing, and then you start to try and force current to flow through that wire. As the current slowly increases, the higher value of current creates a higher value of magnetic field, but to generate that magnetic field, you need to supply energy. So you cannot instantly force a large amount of current to go through a wire. The current must grow from 0 to that large amount, and as the current grows, the energy you are inputting to make the current happen is being poured into the magnetic field until the current reaches its maximum value, and the magnetic field associated with that value of current is created. This phenomenon is what we call inductance. All wires have inductance. Some have much more than others. One more thing about inductance before we move to inductors in a circuit. Suppose you have a wire through which current is already flowing. That means there is a magnetic field generated by that current. That magnetic field has energy. But because the magnetic field has to do with the existence of current, if you try to instantaneously remove the current will not instantaneously stop. The magnetic field that already exists will give up some of the energy in the magnetic field to retain the current that was originally creating the magnetic field. Because the magnetic field can't just disappear without all that energy going somewhere. In order to conserve the energy in the magnetic field must use some of its own energy to try and retain itself. But gradually, the magnetic field's energy decays. Inductors with stronger inductance are composed of coils of wire. The magnetic field that gets set up generally passes through those coils of wire and then comes out and then goes back in. Although all wires have inductance, straight wires have much less inductance than coiled wires. So coiled wires resist changes in current with greater intensity or greater inductance. So an inductor is a device that is designed to resist changes in current because of the strength of its magnetic field. An inductor, which uses current to generate a strong magnetic field, requires more energy to change its magnetic field because there's so much magnetic field to change. We describe inductance with the variable L. If you want more information presented with animations about the basic concepts of inductors, watch the next video in this playlist by Eugene Kutaryansky about inductors and inductance.